Hello, I'm Ramesh Iyer from Team Tricorder, and our project is Headache Track and Predict. This presentation is about our progress so far. Our HTTP application comprises of a UI portion for the end user to add episodes of Headache using either voice interface or using keyboard. We have a backend server that accepts episode information and saves it in the Fire server. Some information such as weather in the area or allergy information, etc. These are also provided from the UI, but we capture these data automatically based on the location of the user, and this information is saved in a local database specific to the backend. Finally, we have a data processing module that uses machine learning techniques to predict the next episode of Headache. We have included the YouTube link for the latest demo, including the UI and UX part for data visualization and predictions. Please feel free to peruse the link and provide us with feedback. On the progress so far, our schedule is currently on track. As part of Deliverable 3, we have successfully concluded Phase 2, which includes a full-fledged dev and QA environment with Docker instances for Fire server and PostgreSQL database. We'll be containerizing our application in the next phase. We have a fully functional UI for capturing headache episodes, and data visualization and prediction. We have a backend implementation to connect with the Fire server and do CRUD operations on it. Also, the backend implementation is ready for CRUD operations on the PostgreSQL DB. We now have mock data which we can use for machine learning and provide predictions. On the concerns side, our main concern is availability of real-world datasets for headache episodes. Our strategy to mitigate this concern is two-pronged. Our TA provided us with dataset that was generated synthetically. We were able to extract observation objects relevant to us. Secondly, we are generating our own synthetic observation data to complement the previous set. Another concern we came across during our discussions with the TA was regarding staging the test data for demo setup. We want to be able to quickly populate the Fire server and our own database to generate meaningful time series visualization and predictions. We are planning to achieve this by populating the database used for Fire server using SQL dump and thus bypass the potentially slow Fire API interface to update bulk data. On the deployment front, we plan to have 3 separate Docker containers, one for the Fire server, one for our DB, and one for the HTTP application. We will use Docker Compose to orchestrate the bring up, and we have accounted in our project plan a module to generate synthetic data that will be injected into the databases at startup. On the next steps, we are implementing the glue logic that ties together all the different components, and we'll be able to showcase the following flows. User entering the episode information, which gets updated on the Fire server and PostgreSQL database, will showcase the visualization of data with prediction of severity and date for the next onset, and we are juxtaposing a real instance of an episode with predicted ones to monitor the error in our machine learning models. Thank you. We hope you enjoyed our presentation, and we are eagerly looking forward to your feedback.